8,000 cars, not stacked in a warehouse, not sitting in a lot, moving, crossing the Pacific Ocean right now, sealed inside a single ship, on their way from a factory floor in Japan or South Korea to a dealership parking lot somewhere in California, Texas, or Florida. 8,000 cars in one vessel. Bumper to bumper, that column of vehicles would stretch for over 30 miles. And this ship swallows all of them in under 48 hours. Here is what nobody tells you about that ship. It is not the vessel you picture when you think of ocean freight. It does not sit low and heavy in the water like a loaded tanker. It does not bristle with cranes and containers like a cargo ship in a harbor. It looks almost nothing like what it actually does. And the way it loads, moves, and protects those cars across thousands of miles of open ocean is one of the most quietly extraordinary pieces of engineering on the planet. The ship is called a Pure Car and Truck Carrier, a PCTC. It belongs to a broader class of vessels called roll-on roll-off ships, RoRo in the industry, named for the only way anything gets on or off: it drives. And from the outside, it looks almost absurd. It sits high in the water, with a hull that rises in an enormous flat-sided block, like someone took a floating parking garage and forgot to make it look like a ship. That's because that's almost exactly what it is. Inside, the ship is hollow. Not hollow in the way a cargo ship is hollow in the way a building is hollow. There are 13 decks stacked inside that hull, each one roughly 14 feet tall, each one a continuous flat floor of painted steel running the full length of the ship. Some of those decks are fixed, some are movable, hinged into the hull walls and raised or lowered by hydraulic rams to accommodate different vehicle heights. A standard car deck, a taller deck for pickup trucks and SUVs, a higher deck still for commercial vans and light construction equipment. The ship reconfigures itself from the inside, depending on what it's carrying that voyage. The total drivable floor space inside a single large carrier is roughly equivalent to 13 American football fields. 13. Laid flat, end to end. Now stack them 13 stories high and wrap them in a steel hull. That's the interior of the ship sitting in the harbor. But none of that matters if you can't actually get the cars inside. This is the part that stops people cold when they first see it. There are no cranes, no lifting, no rigging. Every single one of those 8,000 vehicles drives aboard under its own power. At the stern of the ship, the rear, there is a ramp. Not a modest gangway, a ramp wide enough for 2 lanes of traffic, strong enough to support a fully loaded commercial truck, and angled precisely to bridge the gap between the dock and the ship's lowest car deck, regardless of tide height. It folds out from the hull like the tailgate of the world's largest pickup truck. And through that single opening, a continuous procession of vehicles moves aboard. Professional drivers, called vehicle delivery agents, handle every car. They are not the longshoremen who work the dock. They are specially trained operators who know the exact dimensions, turning radius, and handling characteristics of dozens of different vehicle models. A brand new Lexus with 14 miles on the odometer gets driven up that ramp, threaded through a steel corridor barely wider than the car itself, turned through a tight spiral ramp connecting decks, and parked with inches of clearance on either side. Then the driver walks back down, and the next car comes up. Port terminal loading operations run day and night. At a facility like the Port of Nagoya in Japan, or the Port of Bremerhaven in Germany, the vehicle processing terminal is its own small city. Cars arrive by train and truck from factories and staging lots. They are inspected, their mileage is confirmed, and they are staged in sequence, because the loading order matters enormously. The heaviest vehicles go on the lowest decks. Lighter vehicles go higher. Vehicles destined for the first port of call get loaded last, so they sit closest to the exit ramp. Vehicles going deepest into the voyage get loaded first. Every car's position on every deck is documented in a loading plan that accounts for the ship's balance, its stability in open water, and the sequence of discharge at multiple ports. Unload in the wrong order, and you shift the ship's center of gravity. Get it wrong badly enough, and you don't just have a logistical problem. You have a stability problem. Here is the part that breaks common sense entirely. This ship, this enormous, hollow, high-sided box packed with 8,000 cars, is one of the most top-heavy objects ever to cross an ocean. And it crosses the ocean constantly. Seen from the side in port, one of these carriers would make any reasonable person wonder how it does not simply roll over. The hull sides are tall and flat. The center of gravity is high. The ship barely seems to sit in the water. But that apparent fragility is actually engineered stability in disguise. The ballast tanks built into the ship's bottom are flooded with seawater before departure. Thousands of tons of water are pulled in deliberately to lower the center of gravity and widen the ship's effective base. As cars are loaded and the ship's weight distribution shifts, ballast is constantly adjusted, pumped between tanks on the port and starboard sides, trimming the vessel the way a tightrope walker shifts their arms. By the time that carrier clears the harbor mouth and turns toward open water, it has been tuned as precisely as a musical instrument. The ballast plan and the loading plan are calculated together, one document, because you cannot separate them. Then comes the crossing itself, and this is where the engineering stops being about size and starts being about survival. An 8,000-car cargo is not passive freight. In a storm in the North Pacific, with 20-foot waves and 40-knot winds, every single vehicle on those decks becomes a potential 2,000-pound projectile if it breaks free. One car that gets loose does not just sustain damage. It rolls. It hits the car next to it. That car breaks free. And you have a cascade failure on a steel deck in the dark in heavy seas. This is why every vehicle on board is lashed. Each car gets a minimum of 4 securing straps, steel-threaded webbing straps, clipped to anchor points welded into the deck, and cinched tight through the vehicle's tow hooks or wheel wells. On lower decks, carrying heavier vehicles, 6 or 8 straps per unit is standard. The lashing crew walks the decks and checks every single car after loading and again at sea. The tension of each strap is standardized. Specific lashing patterns exist for specific vehicle types. An SUV lashes differently than a sports car because their weight distribution and ground clearance create different failure modes in a roll. The decks themselves are coated in a high-friction paint, not smooth steel, but a surface that grabs tires and resists the lateral sliding that a ship's roll would otherwise encourage. The ventilation system inside the ship runs continuously at sea, exchanging the air on every deck to prevent fuel vapor from accumulated cars from reaching dangerous concentrations in an enclosed space. Fire suppression systems cover every deck independently. Temperature and atmospheric sensors monitor conditions below decks around the clock. These ships cross oceans that actively try to destroy what's inside them. The engineering exists because people learned, the hard way, what happens when it does not. When the carrier arrives at port after a crossing that may cover 7,000 miles in 2 weeks, the process reverses. The stern ramp drops. The same category of delivery drivers boards, and cars exit the same way they entered, under their own power, one by one, routed to inspection areas, processing facilities, and eventually to rail or truck transport inland. A port like the Port of Baltimore or the Port of Brunswick in Georgia, 2 of the largest vehicle import terminals in the United States, can process thousands of vehicles a day off a single ship. Each car gets a post-voyage inspection. Any transit damage is documented. Vehicles are distributed to storage lots, PDI centers, where final preparation happens, and then dispatched to dealer networks. The car sitting on a dealership lot in Denver or Atlanta may have been manufactured in a factory in Yokohama 7 weeks ago. It crossed the Pacific on a deck 3 stories above the waterline, lashed to a steel floor in the middle of a storm, surrounded by 7,999 other cars doing the same. And it arrived with the odometer reading 14 miles. The next time you walk through a dealership and see that new car smell, the perfect paint, the untouched interior, that car just survived one of the most logistically complex journeys in modern manufacturing. And almost nobody who buys it ever thinks to wonder how it got there. What makes that journey even stranger is what happens at the other end of the port, the customs and compliance infrastructure that every one of those 8,000 cars must pass through before it is legal to drive on an American road. Emissions certification, safety compliance, duty calculation, VIN registration. An entire parallel system built around the same ship, the same cargo, and a very different kind of engineering challenge. If you want to understand that system, stay close. And if you haven't already, hit subscribe, because the machinery behind the things you